Hello everyone, this is Fuge Zou, data scientist from RapidCanvas. Today I'm going to present you a demo on a use case of demand forecasting with an end-to-end solutions using RapidCanvas platform. There are three parts of my presentation today. First, I'm going to introduce the problem statement and the data, followed by exploratory data analysis and feature engineering. Then end up with model training and model prediction using RapidCanvas platform. So let's get started. First, the data we use is an anonymized data from e-commerce online retail store mainly selling clothing products. And we have all their inventory and product information in the past. So we are trying to predict for a given product what will be the potential demand, which means the sales quantity into the future. Here, the business impact will be if you underpredict the demand, so you will be understocked and lose the potential revenue and profits. If you overpredict the demand, you will be overstocked and end up with a potential loss or end up with a lower capital efficiency, right? So a well-suited model here for this company will predict the demand just right. So the online retail shop can maintain a lean operation, which will maximize their capital efficiency and profits. So given the business model, let's move on to the exploring the data. First of all, we need to calculate the label, which is our true demand of this product. So let's look at the decision tree here to understand the concept. Say for example, let's look at this. Say for example, we purchased 1,000 items of a product and it sold 800. So the product is considered as overstock, right? So your purchase is more than your sales. In this situation, we know exactly the demand is 800, and we have overpurchased 200 items in our inventory. So this is a waste of capital, and we will minimize that by predicting the right demand, right? On the other side, if the purchase of the quantity of this product equals to the sales amount, which means this product has been sold out or stock out. And we probably do not want this to happen either, because in this situation, we underpredict the true demand of this product and we are losing potential revenue and profits as well as customers' interest to our platform. Oh, okay, if the customer find our product is stock out all the time, they probably don't want to use our platform anymore. So we do not want either happens. So the best way to optimize these problems is to have a model that we can predict the demand just right, so we can maximize the capital efficiency. In this study, we have applied a simple and effective way to define the true demand for the stock out products, because we have the click data. So that is to get the total clicks of the stock out products and multiply it by an average conversion rate of the entire population. So in this way, we now have the true demand of the stock out products in our database as the target variable. So that is what we want to forecast in our model. So let's move on to a detailed look at the data, right? So this is all our data for this online shopping retail store. We can say for this entire data, we have 4,860 total products. So each row here is representing a product name, right? One type of product. And if you look at all these statistics, that is all the statistics for this product in the past 1 year. So they are clothing products. So you have ID of this product, a product ID, and you have a length of this clothes. And sleeve length is the characteristics try to describe this product. And you have select type, the color, the neckline. These are the clothing specific features you can look. and we have style, fabric, print, print location, fastening location, fastening, print color, pocket, occasion, top type. These are all the specific feature that describe this particular product, right? Country of origin, that is from China, so made in China, and the year is 2020, and year versus 2019, and this is a year, and you have a price and sales and purchase. You can say for a non-stock, like overstocked product, that you have your purchase more than your sales. But for stock out product, you have your sales equals to your purchase. This is exactly what we defined in here, right? And in last not but least, you are gonna our model is gonna capture the true demand of this product. So after that, we're gonna say, okay, this data has all these data types, and they have some null value, as you can see, and we have some unique value. You can see the first row and last row, and you can see overall you have a probably equal distribution of stock out versus overstock products in your portfolio. So the manager is gonna say, okay, I have 50% stock out products, which is probably not good, right? Because we want to minimize the stock out, because that means a customer cannot find the products they want, and we are losing potential revenue and here. So these are all the data definition. So we have 3 buckets mainly. So we have product information. These are the columns or features that describe this particular product. And commercial information are these the sales records, like price, sales, purchase, clicks related to this product, right? This is interactive with the customers. And you have collect information. You have different seasons and different year. This is time related features. And your target variable is your potential sales, which is the number of units that could be sold if the company has enough stock, right? This is your true demand forecasting. Again, like we said, for overstock, it simply means the stock out, it must be estimated from the e-commerce mean conversion. We are using mean conversion rate, try to predict the stock out product. So let's jump into some detailed data distribution, right? We have product info, we have lens. You can see these are the below the bust, waist, below the waist, hips. These are the characteristics defining the product. And you have stock out, yes or no. You can check these 2 dimensions, right? Adding 1 dimension. One is your lens, one is your stock out or not. And you have sleeve lens. You can different size of sleeve. Most of these are just sleeveless, right? You can say stock out, yes or no, right? You can say selected type, colors, which color sells the best. I think that's off-white. And the colors, you have different secondary color of this product. You have neckline, and you have V shape or U shape, or you have details, probably some descriptions, and we have styles. Seems like the slim and the regular sells the best. And you have fabric, cotton is the most of the products cotton. And I think there's no difference between stock out, yes or no, for this like fabric here. They are almost like equally important. So you have print. These are the stripes, absent, floral. You have print location, fastening location. So these are basically the features that describe this clothes, right? We're talking about clothes. And you have checking collect info at its different seasons, either the summer or winter time or all seasons, right? You can most of these like all seasons, and you can say different years. You have 2019, 2020, 21, 22. So this is like all their years of versus stock out. You can say almost like they have lots of stock out in 19, and in 2022 they have most of these are just no stock out, overstocked. So which means the business environment changed probably because of COVID, right? So checking commercial info, you can say this is a price distribution of their products. Most of these are just this is a price count. Most of these is like $50, and you have the price versus stock out. Most of these like you can say more expensive ones have some. The cheaper ones may have some more stock out versus most expensive ones have some some overstocked. And you can say checking numerical feature. You can say stock out versus year versus price. You can say these are the box plot just showing all these different numerical feature against categorical feature. That concludes our feature engineering. That concludes our data exploratory data analysis. So the second part of this talk will be feature engineering for the demand forecasting. Here we'll just apply 3 steps for this feature engineering. The goal here is to make our data set like adding more features that is related to the target variable, which is a future demand, the true demand of this product. And through this data processing, one-hot encoding, and feature selection, we have generated a data set that is ready for machine learning training purposes, right? So target variable, remember we have product demand as target variable. It's necessary to predict the demand of the product. This quantity is not available for a product that's sold out. So we have talked about in the EDA that how we give the labels for stock out products. So we have calculated this conversion rate using the conversion rate on the demand. So this is how we finish the label. Then we did some data processing. So we have dropped some very bad column, bad feature, unrelated feature, or highly correlable features. We have filled the null, make some imputation on the missing values, and we have scaled the numerical feature for basically all these numerical features are in different scale. We make them like a standard deviation of 1 and with a mean value of 0. So that is better for the regression model to work, right? So, and we have used one-hot encoding on the categorical feature. For all these categorical features, we make them like 0 or 1. This is basically a very common technique for feature engineering. So that concludes to the feature engineering step. So after that, we just put the model into our platform. So you can say our platform basically have 2 pipelines. One pipeline is so-called build pipeline. This is where we have use data cleaning and the feature engineering and to train the model. And we save the model as an artifact, right? We use the model and we have a prediction pipeline that is for the new data coming in. So we're gonna check how the model is doing in this build step, and we're gonna deploy the model, which is in real time. For the future, for it will go live, we're gonna do this prediction pipeline. So here we are looking at the model performance first, right? We have the test data that is just we can split the train and test data, and then we're gonna check the performance of the test data, and we're gonna test some filters, right? Different filters. So we have the metrics, right? For the regression model, we have general metrics such as MAE, mean absolute error, mean squared error, root mean square error, and R2 score, right? R2 correlation, effectiveness of correlation and mean squared log error. So we have all these metrics for the model itself, and we also have the business metrics, which is by doing this forecasting, how much pieces we purchased, how much pieces we sold, how much we with extra capital, such a waste of capital we have put there, and the total of lost sales. After the model, we will have an increase in the total cost, but we increase also the revenue and the profit. And the total impact of the total pieces sold is we can, by correctly forecasting the true demand, we can upsell, make an increased revenue by 29%, which is 367K the dollars, the dollar amount, right? So that is a impact, performance and impact of our trained model. Once we have the trained model, just like I said in this prediction pipeline, we're gonna have this pipeline for deployed as an API endpoint and as a cron job. So we can run this every time we have a new product. We can predict the future demand, right? We have any inventory updates. So this is like how that goes. You can upload the table there, just browsing the files. you can update the new table and ask the model to forecast, right? This is one way of doing that. The second way is we have this manual input. We put in all these like parameter of this product, and we can click add input, and that will generate the forecasting for us. So that will basically conclude this demo. So thank you very much for watching. Bye bye.